Here we will solve some numericals on lens and mirror combination. Before starting these numericals, let us recall some basic concepts related to normal incidence in case of a mirror. See, there are two laws of reflection, and there is a law that I is equal to R, that is the angle of incidence is equal to angle of reflection. Here is a phenomenon of reflection, this first diagram. So here OI is the incident ray, OR is the reflected ray, and XY is a plane mirror, and here ON is the normal to the mirror or reflecting surface at the point of incidence. And I is the angle of incidence, it is the angle made by the incident ray with the normal, and angle of reflection is the angle made by the reflected ray with the normal. Now see this second diagram. This diagram is the normal incidence in case of a plane mirror. See here, this is the incident ray moving along the normal to the mirror. So angle of incidence in this case is 0 degree. So the angle of reflection will also be 0 degree as per the laws of reflection. So see here, the reflected ray will retrace its path, or it will go over the same path of the incident ray. And this diagram is the normal incidence in case of a concave mirror. It is a concave mirror. Here C is the center of curvature of the concave mirror. See here are three incident rays, and all the three rays are passing through the center of curvature of the concave mirror. Now in case of a mirror, spherical mirrors, a ray passing through the center of curvature will incident normally upon the surface of the mirror. So after reflection, the reflected rays will go back over the same path of incident ray, or they will retrace their path. So see, here is the incident ray, and the reflected ray will also move back along the same path of the incident ray. So these three are the reflected rays. So it is the case of normal incidence in case of a concave mirror. So in case of concave mirror, the incident ray passing through the center of curvature will follow the same path after reflection, or go back along the same path of the incident ray after reflection. So this is the case of normal incidence of for a concave mirror. Now see, this last diagram is a normal incidence in case of a convex mirror. We know that convex mirror is a diverging mirror. Here these are the three incident rays, and all these three incident rays are heading towards the center of curvature of this convex mirror, and they got reflection at the point P, Q and R of the convex mirror. So as this is the case of normal incidence, so all the reflected ray go back over the same path of the incident ray, or they will retrace their path after reflection through the mirror. So these are the case of normal incidence for a plane mirror, concave mirror and convex mirror. Let us solve some numericals on lens and mirror combination. This is the first question. A convex lens is placed in contact with a plane mirror. An axial point object at a distance of 20 cm from this combination has its image coinciding with itself. What is the focal length of the convex lens? Here it is given that the object is a point object situated on the axial point. That means it is situated upon the principal axis of the lens mirror combination, and it is situated at a distance 20 cm from the combination. Also, according to the question, image coincides with the object. That means the rays after reflection from the mirror M must retrace their path so that they meet again at the point O. See, so in this diagram, see here, these two incident rays after refraction through the lens must meet the mirror normally, then only they retrace their path after reflection. So it is the case of normal incidence upon the mirror. So these two refracted rays from lens or the reflected rays from mirror are parallel to the principal axis. And we know that when the object lies upon the focus of a lens, convex lens, then only the refracted rays are parallel to the principal axis. That means here the object must be situated upon the must be situated at the focus of the lens. That's so after refraction through the lens, rays move parallel to the principal axis, and hence they meet the mirror normally. That's so, as this is the case of normal incidence, that's so after reflection the rays retrace their paths and finally they again reach at the same point O, and hence the final image is formed at the O. So here the answer is the focal length of the convex lens is plus 20 centimeter. That is, the object lies at the focus of the lens. Now let us solve this second question. A point object O is kept at a distance of 30 centimeter from a convex lens of power 4 diopter towards its left. It is observed that when a convex mirror is kept on the right side of a distance 50 centimeter from the convex lens, the image of the object O formed by the lens mirror combination coincides with the object itself. Calculate the focal length of the convex mirror. Here the focal length of the convex mirror is being asked. So here the object distance for the lens, object distance is given. Focal length of the lens is also given as its power is given. So from this we can find the image distance for the refraction through lens. So see here for refraction through lens, object distance U is equal to, here it is OO dash, U is equal to minus 30 centimeter because the point object is situated at a distance 30 centimeter from the lens, and the focal length F is equal to 1 by P, and here power is equal to 1 by 4, power is equal to 4 diopter. So this is equal to 0.25 meter. So this is equal to 25 centimeter. From this we will find the image distance. So image distance that is we have to calculate this image distance. So see, from the lens formula we know that 1 by v minus 1 by u is equal to 1 by f. This implies 1 by v is equal to 1 by f plus 1 by u. So this is equal to 1 by 25. So here u is minus 30. So this is equal to 1 divided by minus 30. So this is equal to 6 minus 5 divided by 150. So this is equal to 1 by 150. This implies the image distance v is equal to 150 centimeter. So this image distance is the image formed by the lens L. Now the image is formed at the point C, suppose, but here is the mirror is placed at a distance 50 centimeter from the lens. So this convex mirror is placed at a distance of 50 centimeter from the lens, but the image formed by the lens is at a distance O dash C, or at this point C. Now according to the question, the image coincides the object. That means there must be a normal incidence in this mirror. That means the refracted rays from the lens, these two refracted rays must meet the mirror normally. That's so after reflection the reflected rays go back over the same path or retrace their path and finally meet at the point O. And that will happen only when the object is situated at the, or object is a virtual object which is situated at the center of curvature of the lens, center of curvature of the mirror, or the incident rays upon the mirror must meet or must approaching towards the center of curvature of the mirror, but due to the reflection they go back over the same path and finally meet at the point O. So already it is given that O dash P is 50 centimeter, but we know that O dash C is equal to 150 centimeter. So it is given O dash P is equal to 50 centimeter. Also we have calculated that O dash C, that is the image distance for the lens, is equal to 150 centimeter. So this implies PC is equal to O dash C minus O dash P. So this is equal to 150 minus 50, that is equal to 100 centimeter. But this PC is nothing but the radius of curvature of this convex mirror, because then only the rays will retrace their path, or then only it will be the case of a normal incidence. So that PC, but PC is equal to radius of curvature of the mirror. But we already know that in case of a mirror, focal length is equal to radius of curvature divided by 2. So this is equal to 100 divided by 2. So this is equal to 50 centimeter. So the focal length of the given mirror is 50 centimeter. Okay, it is positive because the focal length of a convex mirror is positive. Now let us solve this third question. An object is placed 15 centimeter in front of a convex lens of focal length 10 centimeter. here it is given that the convex lens is placed at a distance of an object is placed at a distance of 15 centimeter from the convex lens of focal length 10 centimeter. Now find the nature and position of the image formed. Where should a concave mirror of radius of curvature 20 centimeter be placed so that the final image is formed at the position of the object itself? Again, the final image is formed at the same point or at the position of the object. That means it is again a normal incidence for a plane mirror. For a mirror. Here is a concave mirror, and we will see how the normal incidence occurs in a concave mirror. So see here, object distance is given for refraction through lens. Object distance U is equal to minus 15 centimeter. It is given. Again, focal length F is equal to 10 centimeter. It is a convex lens, so its focal length is positive. Then we have to find the image distance first. See, according to the lens formula, 1 by V minus 1 by U is equal to 1 by F. This implies 1 by V is equal to 1 by F plus 1 by U. So this is equal to 1 divided by 10 minus 1 divided by 15. As the final image is formed at the point O again, so the image formed by the lens must be at the center of curvature of this concave mirror, so that the rays from this point I meet the mirror normally. So after reflection, the reflected rays go back over the same path of the incident ray and finally meet at the point O again. So here V is equal to 30 centimeter. Already we have calculated the value of V. Also, the radius of curvature of the concave mirror is given. So it is asking about the nature and position of the image formed and where should the concave mirror be placed. So what is the distance between the lens and mirror? So let us first solve what is the nature and position of the image formed. We have already calculated the position of the image, that is at a distance 30 centimeter from the lens. Now we have to find its nature. So we will find the magnification of the produced by the lens. So a formula is M is equal to V by U in case of a lens. So here V is equal to 30 centimeter and U is equal to minus 15. So it is equal to minus 2. So magnification is minus 2. That means the image is a real image, and it is greater than 1, so it is magnified. So real magnified image is formed at a distance of 30 centimeter from the lens. So that is the position and nature of the image. Now question is that what is the distance between the lens and the mirror? See here the image distance, that is O dash C. We have calculated O dash C is equal to 30 centimeter, and also it is given that CP is equal to 20 centimeter. This implies the distance between the lens and the mirror, that is equal to O dash P is equal to O dash C plus CP. So this is equal to 30 plus 20. This is equal to 50 centimeter. So answer is the distance between the lens and mirror is 50 centimeter. And so let us see the diagram properly. So here O is the object which is at a distance 30 centimeter from the convex lens. Now there is a mirror at a distance 10 centimeter from the lens. Now the image is formed at a distance of 30 centimeter behind the mirror. We know that from the nature of image formed by a plane mirror, object must be placed in front of the mirror at the same distance, that is the object distance for this plane mirror must be 30 centimeter. So here idea I1 is the object for the mirror and this I1 must be the image for the lens. So now let us find the image distance for the lens. See here MN is equal to 10 centimeter, OM is equal to 60 centimeter, and it is given that NI is equal to 30 centimeter. As NI is equal to 30 centimeter, so NI is equal to NI1 is equal to 30 centimeter, because NI1 is the object distance for the mirror, as the image distance must be equal to object distance in case of a mirror. So NI1 must be 30 centimeter. So here we have NI1 is equal to 30 centimeter and NM is equal to 10 centimeter. So MI1 is equal to NI1 minus NM. So this is equal to 30 minus NM is equal to 10. So this is equal to 20 centimeter. And this NI1 is nothing but the image distance for this concave lens. So see, for the concave lens, for refraction through lens, here object distance U is equal to minus 60 centimeter, image distance V is equal to minus 20 centimeter, because both are at the left side of the mirror, lens. So now see, now we will apply the lens formula, that is 1 by F is equal to 1 by V minus 1 by U. Here 1 divided by minus 20 minus 1 divided by minus 60. So this is equal to (1 divided by minus 20 plus 1 divided by 60). So this is equal to 60 minus 3 plus 1. So this is equal to minus 2 divided by 60. This implies 1 by F is equal to minus 1 by 30. This implies F is equal to minus 30 centimeter.